right, so once we start to get into alkenes, we have some kind of funky rules that happen. So this podcast is going to be a hodgepodge of all those funky rules. So we're going to go over common naming of alkenes. We'll go over dienes as well as trienes here. When you have a very simple alkene, you can use the common naming for that. When we do common naming, we take the IUPAC name and we just change the ending to Y-L-E-N-E. So ethene becomes ethylene. Propene becomes propylene. Butene becomes butylene. You don't see these very often, and you're certainly not going to run into these names very much here in chemistry, but that is a common naming system you may come across. Most of the time we're dealing with alkenes that are a little bit more complex or have groups coming off of them, in which case we defer to using the IUPAC naming system for those. All right, so if you have an alkene that instead of having one double bond has two double bonds, we are going to go ahead and shorthand that. Instead of saying two double bonds, we're going to say there are di or two, and we use E-N-E-S. So dienes are molecules that have two double bonds in them. So when you're naming these guys, you're going to want to count left to right, right to left, top to bottom, bottom to top. Count in every direction because you want to find whichever direction you count that includes the double bonds. You want to find the lowest number of carbon you can for the first double bond. So let's go ahead and count this both ways since it just seems to be left to right and right to left. So 1, 2, 3, 4. So for the green, I have a double bond starting on carbon 1 and I have a double bond starting on carbon 3. Let's go ahead and just double check because we're going to do our due diligence, counting the opposite direction that we don't get a lower numbering scheme. In this case, we have a double bond starting on carbon 1 and we have another double bond starting on carbon 3. I did my due diligence. We are ready to name this guy. So instead of saying that this is butene, because we now have two double bonds and it's 4 carbons long, we're going to use buta, okay, because we want to say that it's 4 carbons in the parent chain. But instead of just saying butene, we're going to say butadiene. That's saying I have 2 double bonds. And right before we say butadiene, we have to identify where those double bonds are. So the double bonds start on carbons 1 and carbons 3. Okay, so this is 1,3-butadiene. If I had a branch, which I don't in this, but if I had a branch, you would put that at the beginning of the name, alphabetize. Again, we're giving precedence to the double bonds for numbering, so whatever number they wind up being is what number they wind up being. All right, so we learned that alkenes have a single double bond, dienes have 2 double bonds, a triene has 3 double bonds in it. So again, we're going to make sure that we're counting in a direction for our parent chain that's going to give the first carbon in the double bond the lowest number possible. So I'm going to do my due diligence. I'm going to count both ways, left to right first. 1, 2, 3, 4, 5, 6, counting in this direction. We start double bonds with 1, 3, and 5. Let's go ahead and count backwards, right to left, to make sure that that's the lowest numbering we can come up with. 1, 2, 3, 4, 5, 6. Okay, in this case, if I count backwards, 1, 3, 5. Oh, these are magically perfect. No matter which way I count, they're perfect. It won't be like that on a test, so be very careful. Always count. Okay, so let's go ahead and start with the parent name. There are 6 carbons in this. So we are going to use hexa to tell us that the parent chain is 6 carbons. And just like in the last example, we said butadiene, saying 2 double bonds. This time we're going to use tri. So this is hexa triene, and that tells us there are 3 double bonds in the structure. Because there's more than one double bond, and because this is a longer chain, we do have to identify what carbon these double bonds start on. Well, I've already counted it all out. So this is 1, 3, 5 hexatriene. If I had any branches coming off, we would name that at the beginning. We'd alphabetize those branches if there's more than one, and they get whatever numbers they're assigned after we give priority to the double bonds for lowest numbers.